Hello everyone, welcome to the class. Today, let's talk about pointers. So what's a pointers? How to use it? Why we need pointers? I think today's topic will be really interesting and very important if you want to be the expert in C languages. Okay, before we start, let's talk about some topic we covered before. So right now, I have a function called func. And this function has one argument, integer argument x. And inside the function, it's update x by assign x plus 1 equal to x. That's it. And right now we have a variable a, which is integer, and we call func a. So what's the output for this? 1 or 0? The answer is 0, because code by value. You remember? When we talk about function, it's called by value, so it doesn't update a, the variable a, inside a function. So if you see the memory, our a variable is here. Okay, so when we call the func, we copy the value of a to the variable x. So this is x. So we copy the value 0, we copy it, pass to the x. Then inside the function, we have x equal x plus 1. We say x equal to x plus 1, so we update to 1. That's it. So it doesn't affect the 0 here because it's called by value. So how you update a? If you want to update a, you need to add something like this. A equal func a, then it's, in this case, it's getting updated by this return value. So you got 1 be assigned to a, then you can bring out a. Okay, so here's the question. If if right now the argument of a func is just there's a 2 arguments, not just 1. Okay, so let's remove this part a little bit. Okay, so right now we have integer x, integer y, and here we have integer a equals 0, integer b equal to 0, and here we want to remove here a little bit. This is should be past a and b. And in the end, we want to update a and b. So we want to update a and b. So we should have something like y equal y plus 1. Okay, so how can we do it? Right now, we have 2 variables, x and y. And we update x equal x plus 1, y equal y plus 1. Which means we want to update a from 0 to 1. We want to move b, change b from 0 to 1. But in this case, we cannot do it, right? Because you can only have one return value. This is the only return value you can have. You cannot return x, y. You cannot. In C languages, you cannot. So if I want to update like more than one variable inside a function, how can I do? Okay, so let's talk about the memory models for this function. So this function, because right now we have a and b, and we have x, y, right? So which means we cannot easily pass the value. We can not easily change the value, these 2 values from 0 to 1, 0 to 1, then go back to update original one. We cannot do it because we cannot return 2 values. However, think about it. If we pass the value, we did not just pass the value, we pass the address of A and B to X and Y. Then we use this address to update the value. How about it? So let's think about it. If we have A, the address A here, so this is address A, this is address B. Okay, so if we pass address A to here, address B to here, which means we know where we know where this data are stored in this memory. Then we can use this address, try to assess the memory location for A and B, then we update. So maybe this can give us a way to update a variable outside of the function. So this idea we call pointers. Okay, so what's a pointers? Pointers is a special variable type. So it's a type allowed programmer to store a memory address. So you can imagine that if you use pointer to define a variable, this variable's value will be an address, not integer, not float, not anything else. It should be an address. You store an address in this special variable, then you can use this variable to access the variable outside of function or anywhere. This is the powerful we have in C languages, which is pointer. So how to use pointers? Before we talk about pointers, let's talk about address. So if you have integer x, your compiler will assign some memory space for this x. So the x should be referenced to this space, and the value for x, if you update x equal to 1, it will store 1 in this memory address. So of course, because it's in memory, that's a memory address, right? So let's assume you have a memory address, let's say 1024. So this is just some random number I choose. Okay, so assume this is 1024 and integer is 4 bytes. So this is 1028. Makes sense, right? Okay, so for 1024, 1028, this chunk is a memory chunk for the variable x. So how to get the address of variable? It's not so difficult. To get the address of x, you can only just use address x. Okay, so actually, if you say address x, for example, I get integer y equal address x, it will give you what? It will give you this number. So you can assign, you can get the address of a variable. Just use this special term, address. Okay, so if you understand how to do it, let's talk about pointers. So for pointers, this is something we can use. We define an integer start. This is the type of pointers. So the pointers type has two keywords. One is the type of what kind of value stored in this memory address. If this memory address is used to store integer, then you say it's integer. Okay, if it's a character, you say character. Then you put another keyword star. So two keywords together, combined together, will be a new type. This type is called pointers. So the pointers is a special type. The difference before the start is only for compiler understand what kind of value inside this memory address you want to access. That's it. Okay, so when we define the address, when we define pointers, we can use the address to assign the value, which is the address of variable, to this new pointer stub. So let's define the integer stub ptr, which is equal to address x. Okay, so in this case, actually right now, ptr, you can imagine that it's equal to 1024. And of course, this is a new variable. So you got the new memory address here by somewhere. So let's say this is 2048. This is 2052. In 32-bit machine, a pointer is 4 bytes. In 64-bit machine, the pointer is 8 bytes. So this is 32-bit machine. Okay, so in 32-bit machine. And this one inside this memory chunk, because it's pointer, we stored 1024 inside this memory chunk for pointers. So the value of a pointers is actually an address. We try to store an address as a value inside another variable. Okay, then we can use this variable no matter where. We can use this variable to access the variable outside of function. So how to access to it? Because the value of this is 1024. So if we want to get the value of the variable is 0.2, we need to say stop. This is the reference. The reference PTR equal, for example, we change it to equal to 2. In this case, first one, this PTR is 1024, right? It's 1024. So it's get the memory address 1024 and the reference. The reference is kind of open box. So you can imagine that I have a memory address. So I only have this address. I don't know what the content in this address, but I can use this address, find where's the box, where's the mailbox. Then I go to the mailbox and use this address, open it. Well, after I open it, I can see what's the content inside this mailbox. So this is the same idea. I have an address. Then this address is stored in some variable, a pointer variable. Then based on this address, when I call start means open. When I open it, I see where's the content. What's the content? Because I know where it is. So I see what's the content. So based on this start, it's use this memory address reference to here, then you got see the content equal to 1. Of course, you can change your content. So I say start PTR equal to 2. Actually, I change 1 to 2. Based on the address, I open it, find the memory chunk I have, then update the chunk. This is a pointer. It's very similar to the concept in Java reference. We use a reference of object to update the object, right? So in C, it's not reference, it's a pointer. With the pointers, the pointer's value is an address, and we use this value, which is address, to access to other memory chunk, then update the data in this memory chunk. So, which means after we did it, if we want to print something, %d and %d. If we try to print something like this, we can print out X, we can print out PTR, star PTR. Then it will print out what? 2 and 2. Because they both are the same. So star PTR, if you dereference this address, it should be equal to the variable you point to. Because PTR point to the variable X, here is point to the X. So dereference, you can get the same value as X. Okay, so let's check it again. So first one, if you want to define a pointers, you will see integer or some float, character, whatever. Then start. Then the variable name. Okay, so this pair of keyword tell you what's a pointer. So with a star means this is a pointer. everything before a star shows what kind of value stored in this memory chunk. Okay, so usually we will assign the address of something, some other variable, other, inside this variable. So this variable stores the address of others. Then if you want to use the value or update the value of other variable, how can you do it? You say variable name, which is the address, we use star to dereference. Okay, so you might get confused. Here's the star, here's the star. I can tell you, don't get confused about it. They are different, totally different. Don't get confused. The star is used to define a type of variable. So the star combined with some other type together to define the type of this one. And this is a dereference. Okay, so like an open. So before you initialize, before you define the variable, you need to define what's the type of this variable, right? And how to define this variable is a pointer. You need to say blah, 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 type star. Okay, doesn't matter what kind of type you want to point to, the size of this variable will be the same because the pointer is used to store the address. Doesn't matter what's the data type stored in this memory chunk, the address should be in the same format, right? So the size of pointer will be the same. Doesn't matter it's integers, a pointer is a floating pointer, it's a character pointer. They are the same. In 32-bit, it's 4 bytes. In 64-bit, a machine is 8 bytes. Okay, this is a definition. Like we want to define this variable is a pointer. The second star here is not a definition. It's trying to dereference. So it's a new operation. Okay, so you say star before variable, you just open this address, try to find the value inside this memory chunk, update it, read it, do anything you want to do it. Okay? Okay, so let's see a more complicated case here. So you can have very special type called integer star x. So what's this? So it's tell you, okay, so you have a star, means this is pointer. But why you have another star? Because this is a pointer point to a memory chunk. This memory chunk store another pointer. So you can imagine that it's a double pointer. You have a memory here, you have memory here, and it's an X. So the X store memory address. So for example, if I have a memory address here, it's called 1024. I store this memory address 1024 here, which means this X variable can point to the memory chunk here, right? What's the type? What's the data type for this memory chunk? It's another pointer. So this should store some address. So this type is a pointer. So you can imagine that if this pointer say, okay, so this is 4096. And in this case, you can find somewhere, which is 4096. Okay, so in this case, this pointer allow you to point to this memory chunk. And inside this memory chunk, it's an integer. So let's say if I have an integer y equal to 0, and I store in here, which is a pointer of memory, which is integer and which is pointed by some pointer. So I have another pointer integer star z, which is address y. So right now we know this is Z. This is Y, right? So Y is an integer variable, so it stores 0 here, and Z is a pointer. Pointer, remember the address of Y, which is 4096. Then it's use this address, can update the Y here. But here's another variable called X. This X equal address Z. So you got the address of this pointer, which is 1024, 1024. You store here 1024. Okay, so it's getting more complicated. You can have like a pointers. You can have a double pointers. A pointer point to another pointers. This is the idea. Okay, so let's see some example here. Okay, so right now, I try to change the variable y. Okay, I can say star z, because z is the value of z is 4096, right? So based on this address, if I open it, I find y, right? I find y. So I can say this is y. This is actually equal to y. Then I say equal 2. In this case, I change the value here by 2. Okay? Then, if I want to read, right now I have another printf, %i. I want to print out star x. What this means? Okay, so let's look at the x. First one, x. What's the value for x? 1024. So this is 1024. So I try to dereference it. I open it. I open 1024. So when I open 1024, I see the value here. So I got the value here. So what's the value? 4096, right? So actually this is 4096. What's this mean? This is the pointers. Actually, this is Z, right? Then we dereference again. So based on this 4096, we open it. So when we open it, we got it pointed to here. So actually, we got the value. 2, which is equal to y. So in the end, this print out 2. Clear? So you can update the pointers by using another pointers. You can also get the value of pointers by another pointers. So it gives you a lot of flexibility to do a lot of like updating or like readings in your C languages. You can read anywhere. Inside function, outside function, doesn't matter. Okay, so if you know how to use pointers, your program will be more complicated and also more powerful. Okay, so this is a form for pointers. Pointers is really challenging topic in C languages, and I believe a lot of you might got confused. You will need a lot of practice, and I can tell you, you definitely need to like do some like testing by yourself, understand the memory model a little bit more, then you can get like familiar with this, because I would say this is the most challenging part like in C languages for this course. And I highly recommend you do some paperwork or just like type some simple example to practice with these pointers. Okay, so I hope you enjoy it, and of course contact to us if you have any questions about it, because I can see a lot of you might got confused, has a lot of question regarding this pointers concept. Okay, so thank you for watching this, and I hope you enjoy. See you next time. Pointer is awesome.